Hello, and thank you for tuning in to the Light It Up podcast. My name is Matt, and I am joined by Tom Garber with Emery Allen. On today's episode, we are going to be talking about the transition from incandescent to LED lighting. And maybe at the end, we might touch a little bit on proper applications and wrap up with bulb enclosures. So, Tom, with when someone's trying to make the transition from incandescent to LEDs, like what issues are they normally going to run into really in any application? Like if you have an older home or building to anything, say like that's been built within the last 10 years, what's somebody likely to run into?
That's a good question. We have a lot less issues the newer the home or the newer the electrical upgrade is to the house. But typically, if somebody's making the transition from incandescent to LED, you can break it out two ways. You have the 12-volt systems and 120-volt systems. The 120-volt systems, very seldom do we get any calls about that. And if there are, it typically has to do about dimmability, dimmer compatibility, and things like that. But before I get into all of this, let me just say that a great tool for everybody to go to, and it doesn't matter if you're doing 12 volt or 120 volt or integrated or drop-in retrofit, Lutron has done a fantastic job writing technical white papers. And if you were to Google just that, Lutron technical white papers, you'll get, some things pop up that you would just click on. It'll take you to a link right to Lutron. And I don't know, you'll have at least 25 technical papers that you can go to that talks about everything from dimming to more things you want to know about loads and forward phase and reverse phase and 0 to 10 dimming and all of that stuff. But it's really informative, especially if you have some of these problems. So backing up from there a little bit, let's just first go into 12-volt systems. If somebody's got an older system, 12 volt, and they're switching over to LEDs from incandescent. Number one problem they're going to have is they have an old transformer. They have an old electronic transformer most of the time, and they'll put a bulb in or they'll put 3 bulbs in, and it'll start flickering. Well, why is it flickering? It's because that old transformer, that incandescent transformer, has a minimum operating load and a maximum operating load, and chances are that you're not meeting the minimum load requirements of that transformer, so it's the bulb's flickering. And you say, why is it flickering? Well, it's the transformer that's trying to start, and every time it tries to start and shuts off again, that's a cycle of on and off. And people call up and say, hey, your bulb's flickering, and it's like, no, I can't make these bulbs flicker. It's the power supply. So we kind of go round and round with that a little bit, and then usually find out that they've got a 5-year-old system that is incandescent based, used to operate 1 or 2 50 or 60 watt bulbs. So let's say it's a 150 watt load transformer or even a 75 watt load transformer, and they put 1 5 watt or 2 5 watts on. The load is only 5 or 10 watts, and the transformer just sitting there trying to start, and all it's doing is flickering. So we get people to switch that out, and 90% of the time that takes care of it. The other thing that can happen if they do have a dimmer and the system is that old, it will probably be a incandescent type dimmer. Again, you go to Lutron's website, and they tell you with dimming low voltage that you always want to use an electronic low voltage dimmer to get the best type of performance out of your bulbs, the dimmers, and all of that. So that's when it can get to be a little bit costly also, because ELVs are not, your standard $20 LED dimmers. Mm-hmm. They can run, $50, $75 and up just for an ELV dimmer. If there's just a toggle switch on and off, then just by switching over the transformer, that's pretty much going to go away. So let's go into the second part of that. If it's an older system, or maybe it will be tied to something else, they could have a magnetic transformer. Magnetic transformers are great. They're all tried and true. There's no minimum load requirement. Just load that thing up to 80% as the NEC recommends. Use a magnetic low voltage dimmer or an MLV, and you should be good to go. Biggest thing is trying to find some of these transformers, if they're inconveniently located either up in the ceiling in a canopy or in a cabinet, that can be a little bit difficult. But that's basically the couple things that there are with the older 12-volt systems. Getting into the 120-volt systems, again, it's there's two things that we start asking the questions. Number one is how many lights are on the circuit. What type of switch are you using? Is it a toggle on-off switch, or is it some type of a dimmer? If it's a toggle on-off switch, then there's no problem. You might just have a bit of a loading issue. But if there's a dimmer on it, chances are it's an older incandescent dimmer, which needs to be changed out to the the 153 series, like a Lutron 153 series dimmer. The only other things that we get into are some commercial applications. They will have one switch, one dimmer switch that operates 40 or 50 lamps. And if you were to see our report card from Lutron, you would see that a lot of our bulbs for the 153 series are good up to 33 bulbs on a particular dimmer, and that's because those dimmers are rated at 150 watts. The other ones are rated at 250 watts, and sometimes you can use that to help solve the problem. If the load is still more than that, then that's what they don't want to hear, because they have to run a different or a second circuit in order to dim, a second set of fixtures, and that starts to get a little bit costly.
So let me throw a little bit of a curveball in at you. You might have to put on your salesman hat a touch. But so everyone's hearing all that's going on. So what now is the benefit of switching over to LED from incandescent? If they're like, oh, I gotta look at a new transformer. If I'm in a 12-volt system, I have to look at $70 dimmers. If I have to do this and that, what's the overall benefit in switching over to LED in general? Here's your salesman's hat.
Well, that's a very good question, and it's not a salesman hat. It's just really a matter of fact. It's just, we sold a ton of our product in Vegas and a lot of the casinos out there and the theme.
And it's not even Emory Allen. It's just like, why would somebody want to go to LED in general?
Oh, sure.
Over incandescent.
Yeah, no. And I'm saying this, as a general fact.
Yeah.
That, it doesn't matter, whose product it is. It's good quality product. And, you're going into hospitality or anything like that. What's the major cost that's associated? And you can look at it one of two ways. It's either the cost of maintenance or it's the cost of energy. You got to figure that, a good LED product is going to be saving you 90% or something like that. So there's that cost savings. Mm-hmm. But what about that versus the maintenance cost? Let's say that a standard halogen incandescent bulb lasts around 2,000 hours. A good LED will last you 15,000 hours. So if you calculate that out for a maintenance person to go around and change out all those bulbs, that's one thing. If you look at it, let's just say an LED bulb is 2 times the cost of a good quality incandescent or halogen. So, the payback is, 2 or 3 times. The people that really see a significant, savings, the people in Vegas or the people at the casinos. Because if they've got to shut down a couple of tables or slot machines or something like that, they could care less about the energy cost or the maintenance fee. Mm-hmm. It's like how many, tens of thousands of dollars are they using to rope off a couple of tables and bring in some scaffolding and change
the guy with the scissor lift out there to...
Yeah, exactly. And disrupt everybody from gambling. So, that's kind of like a real no-brainer. But in the, in a typical home, I don't know if I should say this, but it's the pain in the ass factor.
Yeah.
It's, oh my gosh, I just replaced that halogen light. It seems like yesterday, but it was, maybe about 1,800 hours ago. It's not a very long amount of time. Or it's, replacing the incandescent candelabra bulbs in your outdoor fixture in the middle of wintertime. It's just like, that's not a lot of fun, especially if you drop a little thumb screw in the snow or in the rocks someplace. Mm-hmm. And we've all done that. So, there's a certain convenience factor. There's definitely the cost savings. We're at about a 90% cost savings, and then you change the bulb out once or twice, and you have your money back.
Yeah.
So, that's the biggest thing. Those are the biggest points right there.
Yeah, definitely. So a lot with this, like, what do you say in terms of like fixing a lot of these issues that we just touched on? So, what is someone really going to be looking at specifically, like, as far as like load requirements, as far as like, say, like inrush current, which I don't think we've touched on yet. I believe we touched on transformers and dimmers a little bit. We were talking a little bit about the white papers from Lutron, and we might link that in the show notes for this podcast. But so say you have like some specific load requirements that you need to meet or that is recommended to be met, or you have some inrush current. And I know that in many places, and Emory Allen offers it as well, you can go on the website and you can find an inrush calculator just so you can see. And it's relatively generic, even though the back end is a little math heavy, but is relatively generic in terms of you just plug in your situation and it tells you what you should be able to do on a specific run. So how would you figure that some of these issues that we just described could be fixed?
Well, the transformer issue is really easy. If you drop a canopy or look at your under cabinet light or something like that. You'll open it up and you'll see what type of transformer it is, and it will say right on there halogen, incandescent, or it'll say LED. If it says LED, you're probably okay. So that's one thing. It's just read what the transformer is, what type it is, and what is its intended use. So you touched on a good point with inrush current. We haven't talked a lot about that. But, with inrush current, when you change from incandescent to LEDs, you have to deal with one thing that's called inrush current. And that's just the initial charge of all of those components inside of either a light bulb or a fixture or integrated fixture or what. So when you have a transformer that's separate from the bulbs, then that transformer has a rating. It has a maximum wattage rating that is rated at an incandescent load, because the LED transformer will operate incandescent as well. But so it's rated at 60 watts max. When you go ahead and calculate, what's your, loading for that particular transformer, you need to downrate it, I would say, to be safe, 50%. Now, you might say that 50% is an awful lot, but there's a big difference from one person's, bulb that is, one person's MR16 and another person's MR16 that produces the same, relative amount of light. You could have double the inrush current. And, that's things that, we've measured here, and, people have measured, for us on the outside. So, to be safe, I would, I downrate all those transformers 50%. What happens if you don't do it? You might still see some flickering, or if it's on the threshold, you might wind up heating up the transformer. The internal components might cut it off and turn it on until turn it back on when it cools down, and you get that cyclical thing going on. If you downrate at 50%, you're probably pretty good to go. One of the things that we're going to get into in future podcasts, and I kind of had the conversation with a couple of buddies from years back, is that with LEDs and all, should there be an inrush current value on the specifications so that you know exactly how to load a particular product or a particular circuit? So it's going to be an interesting conversation, and these are the kinds of crazy things that we get into when we meet at ALA's engineering subcommittees. We bring up crazy things like this that at some point wind up being a requirement, and it's not. Can you tie a safety feature to it? So UL can get involved or something like that. I don't know, but it's more of a convenience thing more than anything else. So if a person is using a lot of this type of product on a particular circuit, so that they can plan accordingly. So those are some of the things that we're going to talk about in future shows and all of that.
So in general, you have somebody who just pulled out some halogen bulbs. How do they go about finding something that's not going to be obnoxiously bright, or going from a pretty darn high wattage with a halogen bulb or any incandescent bulb to now they're seeing 3 watts, 5 watts, 6 watts? How are they going to find the best compatible bulb for their application to not really change things up too much. So when they make that switch.
That's a good point. And the point is, it's good for two reasons. Number one is you can get into the situation where you're producing too much light and it's too bright for a particular application, such as a step light in landscape lighting. You used to have a 918 bulb or something like that, and then you stick something in there that produces 300 lumens, and one step light lights up your entire backyard. So there's that whole thing. Then there's obviously an overheating issue. So
we can touch on overheating in a little bit down the episode, but more just from a general light output, like finding the right bulb to replace what was previously in that application. Like what's the best way to do that, really without too much financial experimentation?
I think it's real simple. Is you figure out, it's a one section Google search. If you had a 10-watt halogen bulb, Google how many lumens are in a 10-watt halogen bulb, and it'll tell you how many lumens, 100, 175 lumens. Find the comparable LED that produces 150, 175 lumens, and switch it out. If you go over that, you could be getting to other problems, but in general, I would stay around what was originally intended.
So as easy as a Google search.
As easy as a Google search.
You can also call most manufacturers, and they'd be more than willing to walk you through it as well. So what about this is kind of going to touch off the whiteboard. So it's like, okay, let's get into the nitty gritty. What would you say someone replacing something per like color temperature? And this almost comes down to geography as well.
Yeah, there's a couple of different things. If you had halogen in there before, I think halogen, I'm just doing this off the top of my head, halogen produces light at about 2850 Kelvin. Incandescent is slightly less than 2700. If you had halogen before and you liked it, I'd go as close to that as possible, which is looking at 3,000. If you want something a little bit warmer, it's 2,700 is a key target to go with. And you bring up a good point with geography and all of that. With people moving here from all over the world. You could have somebody from South America who is used to whiter, brighter light, or from, different parts of Europe are used to that as well. And, they might want 4,000. I got a call last week from somebody that says that he's got a customer, all they want is 5,000 throughout their whole house. So, that's the rule of thumb. If you like the standard incandescent, then 2,700 is where it's at. If you want something a little bit whiter and brighter, then push it up to 3,000. You'll be closer to halogen.
And you're also finding that it also comes down to, let's say, like architecture of a house, then how the lighting is implemented. You're going to find whiter lights and more of like modern applications, whereas you're going to find warmer color temperatures when you get into more like homey and cozier and like traditional applications as well. So it's definitely something that I think in the future we'll probably be releasing some blog posts and whatnot, and really be focusing on home applications, architects, the hospitality industry. I mean, no one likes going into like a hotel when you got like 4,001 light on the side of the bed and you got 2,200 on the other side of the bed. So we'll definitely be touching on that later.
Oh, it's even much more than that. I mean, it's even into retail. We went out recently and bought a new table. And in the furniture store, they had a whole rash of garbage lights up. The lights were actually fighting each other. There's fluorescent mixed with some halogen, mixed with some incandescent, and we really couldn't tell what the color of this table was. And it truly was a lot different color once we got it home in natural light and all of that than whatever the store had. But we were okay with either color, either brown or gray. When we got it home, it had a tendency to look a little bit more brown than gray.
I mean, it even comes down to say that you're replacing like an MR16 and you're gonna, and you refer an indoor application, you pick up an MR16 that has 4 or 5 LEDs in it, as opposed to one that just has like one single LED, and now you're going to have all these different shadows everywhere from the multiple LED points.
Everybody,
that can get disorienting too.
Everybody's going to the single point source, and it makes a lot of sense. On the interior side of it, people don't want to see shadows crossing over and everything. They want one point source. And if you look back, that's what a halogen bulb was. It was a single point light source. It didn't have 8 halogen bulbs directed into one area.
And this is mainly for indoor application.
Yeah, but I think even for architectural outdoor landscape lighting, you're shooting up, you're lighting up a side of a wall or whatever. You don't want to see the different striations in with the multiple LEDs either. So the single point was the direction that things have been going. So just to recap here, just real quick, because this is one of the most asked questions either by email, phone calls, or whatever. Somebody calls up and says, "Hey, I have a problem with my 12-volt lighting. The bulbs are flickering." So we look for incompatibility, first of all, incompatibility issues with transformers, with dimmers, and with loading. So the first thing we'll do is we'll say, is there a transformer? Or is this an old application? What kind of bulbs did you have in it before? Was there a dimmer? Go through the same amount of questions. So then the next thing we'll do is we'll say, need to consider replacing the transformer from a halogen to a LED transformer, and we'll go through the whole thing again with minimum and maximum load recommendations based on that particular transformer. Use the right dimmer. Always use either an ELV or an MLV for an electronic or a magnetic transformer. Load them up properly. Take into consideration inrush current when dealing with electronic transformers. And if you have a question, you can always call or email us. With 120 volt, it's a lot easier. You're changing out incandescent 120 to LED 120. Look at using or switching things out to a LED compatible dimmer, and those are very easily available at local lighting showrooms, electrical distributors, or even big box stores. It's a very easy transition. Sometimes people get into some dirty power and things like that, and if they do, we have suggestions for them. And then again, Google Lutron technical white papers. They have a load of information on there about dimming 12 volt and 120 volt systems, areas that I haven't even gotten into. And I think that's about it.
You want to touch at all on, say that you're replacing a halogen bulb with an LED, and you got an interesting enclosure that is going into, like an interesting application, and there's certain regulations and whatnot that LEDs have to meet, but sometimes things can be a little tight.
Yeah, well, we're kind of going into the next section of this, and we'll touch base and kind of roll into that then. And when you're making the transition from incandescent to LED, and we're talking about incandescent halogen. Halogen is still considered an incandescent bulb when a particular fixture is designed. UL 153, 1598, whatever the standard was at the time, will say that you have to have a bulb containment barrier on that said halogen bulb, just in case for some reason that bulb were to explode and hot particles of glass could fall on carpeting paper or whatnot that could catch on fire. So the enclosure was meant to go around that bulb, so if the bulb did blow, it would be contained, within that area. If you're switching out from from an incandescent halogen type to a LED bulb, take that bulb containment barrier and throw it out. It doesn't do anything for you when it gets to an LED standpoint. You're not voiding any UL codes or anything like that as long as you are using an LED bulb. An LED bulb is not a pressurized device, so there is no fear of this thing exploding or anything like that with the halogen bulbs. And the only thing that bulb containment barrier is doing is holding the heat in to that LED and causing it to fail at a much more rapid rate than was originally intended. So that's the biggest thing that we get into when transitioning from halogen to LED is you come across those containment barriers, throw those away, and then that's pretty easy. So let's just touch base real quick on enclosed fixture ratings. All of Emery Allen's product is rated for enclosed fixtures. A lot of other people's product are rated for enclosed fixtures. That doesn't mean that you can take the largest lamp and stick it in the smallest surface or diameter or sphere or whatever that you can possibly fit it in, and it will work. That's not the case at all. What it means is that the product has gone through some other extensive testing that it is good for the enclosure fixture rating that Underwriters Laboratory and the American Lighting Association has come up with. And basically that enclosure is a cylinder that's 6 inches in diameter and 8.5 inches long. If you close that thing off on both ends, it's about 290 cubic inches of air volume. So that's quite a bit. So if you were to take a 4.5 watt bulb and let's just say put it into a 1.25 inch diameter metal tube with just the end out of it with a glass cap or something, you've got basically maybe a cubic inch of air. That thing's going to fail in a skinny minute. So we need to do a little bit better job of explaining what an enclosed fixture rating is. So let me just back up and, why is there all of these heat ratings and all of that as well? Well, every component in an LED lighting device has a temperature rating on it. And, I don't care if it's a, capacitor or silicone or polycarbonate. Either the manufacturer or UL has come up with a thermal rating index. So, so you cannot exceed, these temperatures. If you do exceed these temperatures, UL will typically say, this product won't pass. And we have to, and every other manufacturer who has a UL rating on a product, they make sure that the components are never exceed those temperatures. So what happens if you have a product that's past an enclosed fixture rating? They will make sure that the inside components, the thermocouple test point, and all of that are all within a certain range. And certainly, if somebody takes and exceeds that temperature or exceeds that size, you're going to get a product to fail very, very quick. Our products, and most products that are UL rated and have some type of a Title 20 or JA listing will be, have a 25,000 hour life or something like that. If you were to take these same products and put them in, that small of an enclosure, you can get failures within several days. Mm-hmm. And that's just, basic thermodynamics. I mean, there's certain things that you just can't prevent happening. LEDs produce a tremendous amount of heat. It's all about how that heat is managed, and get the heat away from the LEDs, get the heat away from the components as quickly as possible. It's easy to do it in an enclosed fixture standard. Not so much if you're doing it in the types of fixtures that I was explaining about earlier.
Mm-hmm. Yeah, definitely. No, that's good. So, kind of one of the last things, and I suppose it's a bit of a housekeeping point. So, what's the best way? And it sounds novel because it's a light bulb. But what's the best way to install these bulbs? Do I just go like a normal light bulb and I just unscrew the hot one and I just go screw in the regular one, it lights up and we're good? Or is there any type of precaution I need to take? And what can I, is there anything that I can screw up by just plugging this guy in where the old one was?
Yeah, you're pertaining to hot lamping. And, this is a subject that has come up over the last, several years. And you never want to plug in a LED bulb into a live socket. You go ahead and you screw that bulb in or plug it in, and it's a live socket. There could have a little bit of arcing between contacts. When you're doing that, the amperage can be, off the charts, and you could just shorten the life of those bulbs. And think of it this way. Would you ever do that to a halogen bulb? If this was a 100-watt halogen bulb, would you ever screw it in when it was turned on?
Probably not.
Probably not. So do the same thing with an LED, but what you're doing is you're extending the life of the LED by keeping it off. If you can't, find the lights, the socket or something like that, use the flashlight on your phone.
Well, there you go. Tom, you have anything? I think we've just about covered everything. Do you think there's anything left unsaid for this episode?
I'm sure there is. Like I said, there's these are the two most covered topics. People calling in and all of that. On a weekly basis, but we offer the opportunity to send us an email or call us, whatever, and we'll feature your questions on other shows for questions and answers segment. Use the manufacturer's recommendation for enclosing bulbs and integrated fixtures. Use their ratings of what they recommend. Don't misuse the products. The biggest thing that's going to happen is you're not going to get the life that you expected out of them, and you're spending money for naught. So I think that's it.
Well, very cool. If y'all have any questions, feel free to write in. I think as of right now, we're just keeping it relatively informal, and you can just write into Tom at his email, just tomg@emeryallen.com. And if you had any questions you have to him, and probably around episode 10 or so, we might be looking into a little bit of a Q&A episode. So if you like what you heard, feel free to drop us some likes, some stars, some comments. Feel free to subscribe to this podcast.
Or if there's anybody that you want to hear from, I'd like to know more about this, or I'd like to know more about that, or hey, can you?
Oh yeah, any questions you have, or if you have any topics that you'd like to hear. So definitely feel free to be vocal. We're all about creating a community that just more nonetheless just talks about this, as opposed to just kind of like hides behind a little bit of a veil. So like I was saying though, if you like what you're hearing, feel free to drop any likes, comments, stars, thumbs up, whatever is wherever you are. We'd love if you were to subscribe to this, and we'd love any feedback on what you think about the podcast. So we appreciate y'all listening in, and we'll catch y'all on the next episode.